Hi students, how are you? I hope you all are fine and safe. Stay home, stay safe and take prevention for COVID-19. The same thing I am also doing in home. So we are going to discuss about the next part of the coordinate geometry. The next part of the coordinate geometry is the derivation of area of a triangle. You already know what is the area of a triangle. Very easy, half into base into height. But in a coordinate geometry, when you are deriving the area of the triangle in a coordinate geometry, then it will be something different. So this is the discussion matter today. So now you see what I did. I just go for a Cartesian plane. In that Cartesian plane, what I did in my first quadrant, I took a triangle. What is the name of the triangle? The name of the triangle is ABC. Okay, according to that, I gave my coordinates also. A point coordinate is x1 and y1. B point coordinate is x2 and y2. And C point coordinate is x3 and y3. So these three coordinates I took for triangle ABC by naming ABC. Clear now? Now what I did see, I drop the red line. I drop some perpendicular. Understood now? I drop perpendicular from B point to x-axis. What is x-axis? X dash x. X dash is the x-axis. So I drop perpendicular from B point to the x-axis. Then it is touching the x-axis at Q. Now another perpendicular I drop from A and it is touching the x-axis at P point. Now another perpendicular I drop, that is from C and touching the x-axis at Q. So the three perpendiculars drop, they are touching at Q, P and R in x-axis. I am again saying in x-axis. So you are dropping the perpendiculars to x-axis. So BQ is perpendicular to x dash, that means x-axis. Similarly, AP is perpendicular to x dash. Similarly, CR is perpendicular to x dash. So give the naming of the perpendiculars, that is Q point, P point and R point. So BQ is a perpendicular, AP is a perpendicular and CR is a perpendicular drawn to x-axis. I hope you understood. What I did, first I took a triangle, then I named the triangle ABC and give the coordinates for the points. Point A coordinate is x1, y1, point B coordinate is x2, y2 and point C coordinate is x3, y3. Then what you did, you just drop perpendicular, that is from B point, A point and C point respectively. Then BQ is a perpendicular, AP is a perpendicular and CR is a perpendicular drawn to x dash, that means x-axis. I hope you understood. Next, the most important point is that you have to go for the measurements in x-axis and the measurements in the y-axis. So the measurement in x-axis I took from all the measurements I said you, it will be from origin. So origin is here now. So what is O to Q? O to Q you are going in x direction, that means x-axis. In x-axis what is the coordinate here? x2. So I wrote O to Q is x2. Now you see O to P. O to P is, what is the coordinate in x-axis? That is x1. So I wrote here x1. O to P. Now O to R. O to R is in this C, that means it is x3. The coordinate is x3. So O to Q is x2. O to P is x1. O to R is x3. So we got the three measurements for these distances in x-axis. That is OQ and for OP and for O to R. x2, x1 and x3 respectively. Now you see what I did. I did this small distance. What is this small distance? Q to P. Okay, very easy. Q to P. What is this in x-axis? In x-axis. What is this QP? Now this OP minus OQ. OP minus OQ. So x1 minus x2 is this much. So this distance QP. I hope you understood. Next, to find out the distance between P and R. P and R. What is the distance? The x3 is the total distance and what should be minus? That is x1. So x3 minus x1. x3 minus x1 is your PR. So all the measurements in x-axis, it is already over now. OQ, you got it. OP, you got it. OR, you got. Then you got QP. Then you got PR. So all the measurement in x-axis is over now. Now go to the y-axis. What is the y-axis? See now. This vertical is y-axis. So what is the y-axis? First it is from B to Q. B to Q is y2. I wrote here y2. See, this is y2. Now it is y1 from A to P. This is y1. Okay. Now from C to R. This is y3. So very straightforward measurements are there. y2, y1, y3. That is BQ is y2, A to P is y1, and C to R is y3. I hope you understood all the measurements I took now. Okay. Now what to do? I am saying to you, after this all, you go through the notes. That means in triangle ABC, I wrote for you how to derive the formula. In triangle ABC, so this is the triangle ABC. What is that? A point you wrote x1 by 1, B point you wrote x2 by 2, and C point is x3 by 3. I hope you understood it nicely. When you will do it in your rough note, running notes, you have to mention these things very accurately. Then we will decide the area of the triangle. Then from B point, what from B point you did? From B point, from A point, and from C point, what you did? You drop perpendiculars. You drop perpendiculars to x-axis. That means x dash. So now you see BQ perpendicular. This is the perpendicular symbol. You can write perpendicular like this also. You can write perpendicular like this also. So perpendicular BQ perpendicular to x dash, x dash. That means towards x-axis. AP is perpendicular to x dash. Next is CR. C to R is also perpendicular to x dash. So x-axis perpendicular you already draw from 3 points B, A and C. BQ, AP and CR are the perpendiculars from the points of or the vertices of the triangle, that is A, B and C. Understood now? Now you see in x-axis, I go for the x-axis measurement now. Just now I said you how to do the x-axis measurement. What you did, you write it here. What is O2Q? O2Q in x-axis. This is x2. Now I wrote x2. What is O2P? O2P. Now what is this? In x-axis, this is x1. Very easy. Now you go for O2R. What is O2R? In x-axis, that is x3. I wrote it here. OQ is x2, OP is x1, and OR is x3. That everything must be written accurately. In place of 2, you will write 1. In place of 1, if you write 2, then all the things will go wrong. So for that reason, very carefully you write these things. Then what I said to you? I said you this small distance and this small distance. What is this small distance? This is the OP minus OQ. OP minus OQ. So OP is x1 minus x2. So this small distance is x1 minus x2. This is in x-axis measurement also. For that reason, we are going to write that. What is QP? I wrote it here, see. OP minus OQ. OP minus OQ. x1 minus x2. Understood now? Next, what is PR? P to R. This is OR minus OP. OR minus OP. What is OR? X3. What is OP? X1. So it is written as, what is OP? O to P. You see. What is this? OR, O to R minus O to P. What is O to P? X1. So it is X3 minus X1. X3 minus X1. Clear? Understood now? So now, what is QR? Q to R. Now this plus this, QP plus PR is giving you QR. So what is QR? QP plus PR. What is QP? X1 minus X2 plus X3 minus X1. So minus X1 plus X1 cancel. It is X3 minus X2. X3 minus X2. I hope you understood Q1. Q to R. So in x-axis, finally I am saying to you, in x-axis what you are going to do, you are just writing the measurements according to the coordinates. So look, first O to Q, x2, O to P, x1, O to R, x3, direct coordinates. Then what you did? This small one. This minus this. x1 minus x2. x1 minus x2. This distance. The whole minus this one. So whole is x3 minus x1. This one is x1. So x3 minus x1. It is written there. Then what you did? You just add. You go for the Q1. What is Q1? QP plus PR. QP plus PR. x1 minus x2. x3 minus x1. So add it. x1 will be cancelled. Then it will be x3 minus x2. This much distance is x3 minus x2. Clear now? Now which part you are going to do? It is the most important part. See now what I am doing. I did a skeletal figure here also. Of this figure, I already did a skeletal figure here also. You see. What we have to do now? We have to determine the area of the triangle. Clear? So what is the area of the triangle? In coordinate geometry, in general it is half base into height. In Heron's formula, we are going to discuss about it. But in coordinate geometry, the area of the triangle, we are going to derive it now. Now you see, what I did here, I just took this figure to here, transfer this figure to here. And what I want to explain you that, see now, the area of the triangle, what is the area of the triangle? Look at it. Either dotted are there, some dot marks are there. What is that? A, B, Q, P. What is this figure? This figure is a trapezium. What is this called as? This figure is a trapezium. So BQ and AP are parallel sides. See, BQ, B to Q and A to P. These two are parallel sides. So these two are non-parallel sides. So definitely this is a trapezium. What is that? A, B, Q, P. Write that. Area of A, B, Q, P I wrote here. Plus, what is this one? Again a trapezium. Yes or no? These two are parallel sides. This one and this one is parallel sides. These two are non-parallel sides. So A, B, R, C is also a trapezium. So area of this trapezium. This is in wrong mark. I put it wrong for it. I put it dot for it. Okay. So ABPQ is a trapezium. APRC is also a trapezium. When you will add these two trapezium, the whole figure is coming. See, this one plus this one is giving you the whole figure. From that whole figure, we are going to subtract this trapezium. Then what is coming? See, in my hand. What is coming in the ABC is coming. You are going to subtract this. You are adding this and this. But it is giving you the whole figure now. Area of the whole figure. Then what are you going to do? You are going to subtract this area. Then what is coming? ABC triangle area. That is, it is written here. Area of trapezium ABQP plus area of trapezium APRC plus or minus area of trapezium BQRC. This trapezium. Just go to my hand. This trapezium. So you already took this trapezium. When these two are added, the whole area is coming. When the whole area is coming, you are going to minus this trapezium area. Then you are getting ABC triangle area. So area of BQRC trapezium. So that one I wrote here. See now. I hope the skeletal figure you understood. So now here you see this is a trapezium. Okay. A, B, Q, P. Now it is A, C, R, P or A, P, R, C. So this is a trapezium plus area of this trapezium plus area of this trapezium is giving whole figure now. Area of whole figure. If you are going to subtract this one, see what is remaining? ABC. The area of ABC will come. So that is written here. Now area of triangle ABC equal to area of trapezium ABQP. ABQP, this trapezium area plus this trapezium area APRC. Now minus this trapezium area. See what is coming? ABC triangle. Area of ABC triangle. I hope you understood. BQRC minus area of BQRC. Now one thing you have to know that what is the area of a trapezium. Area of the trapezium is half into height into sum of the parallel sides. Half into height into sum of the parallel sides. See, one by one I am putting it. Area. What is the area of trapezium? ABQP. ABQP. What is the area? The area is half into. What is the height now? The height is this one. See, this one is the height. QP. What is that? X1 minus X2. I wrote half into height into sum of the parallel sides. What is this side? Y2. What is this side? Y1. So Y1 plus Y2. Y1 plus Y2. Understood now? Then plus area of APRC. Half into height. This one. APRC. Height is here. Height is PR. Half into X3 minus X1. I wrote height. Plus sum of the parallel sides. Y1 plus Y3. Y1 plus Y3. Next minus. We have to deduct what? This area. This area we have to. This is also a trapezium. So what is the height? This is the height. QR. What is QR? QR came here. X3 minus X2. Put X3 minus X2 into sum of the parallel sides. What are the sum of the parallel sides? Y2 plus Y3. Y2 plus Y3. After putting that, now place is not there, but these are the measurements we have and solve to get the area. To solve to get the area of the triangle ABC. Now you see, I hope you understood all the theory behind it to determine the derivation of area of a triangle. Sometimes in exam derivation will come. Now we are going to solve this one. Okay. Now you see what I wrote. The area of the triangle is equal to what it can. It can half into x1 minus x2 into y1 plus y2 plus x3 minus x1 into y1 plus y3 minus x3 minus x2 into y2 plus y3. The half I took common here. So the half is taken common. After that you put it in a square bracket. You put it in a square bracket. Students, this is the most important part. From here onwards, it will give you the area of the triangle. But it has a lot of multiplication, see. So carefully, and also many numbers are involved here. 12, 31, 13, 32, 23, like this. So if the numbers will come, it will not come accurate, definitely this area of the triangle will not be solved. It will be wrong. For that reason, be careful and do. See my multiplication, how I am doing it. See now, half x1 into y1, that is x1 y1. x1, then it is plus into plus. Plus, say it like this with me, by which the signs will also come right. x1 into y2, x1 y2, minus into plus, this is minus, x2 y1, x2 y1, minus into plus, this is minus, x2 y2, y2 y2. Say like that and write, by which wrongs will never come. Now you see plus into plus, this is plus, x3 into y1, plus into plus, plus x3 into y3. Now it is minus into plus, minus x1 y1, minus into plus, minus x1 y3. Then here it is a negative sign. So what you are multiplying, you write it in a bracket. This is important. Write in a bracket. The thing inside, it will be again multiplied with this negative sign. So many students, they will not keep this bracket. So what will directly, it will come minus x3 y2. So it will be wrong. So minus is there, put the minus. Give a bracket for your multiplication, that is x3 into y2 right here. Then x3 plus y3, x3 into y3, this is plus. Then minus into plus, minus x2 into y2. Next it is minus into plus, minus x2 y3, x2 y3. Now in the next step you multiply this sign with all to solve it. Right now see what I wrote, that is implies half into x1 y1, x1 y2, minus x2 y1, minus x2 y2, plus x3 y1, plus x3 y3, minus x1 y1, minus x1 y3, minus into plus, minus x3 y2, minus into plus, minus x3 y3, minus into minus, plus x2 y2, minus into minus, plus x2 y3. Now we already multiply this minus sign with all, and it is coming like this. Now what the thing you have to know, see now, you have to see the cancellations. What are going to be cancelled here? Now you see x1 by 1 in plus. Now I am writing here, see, x1 by 1 in minus. So these two are cancelled now. Clear? Understood? Now you see minus x2 y2. x2 y2 in minus. Then x2 y2 in plus. So it is also cancelled. Now x3 y3 in plus and x3 y3 in minus. What is x3 y3? x3 y3 in minus. It is x3 y3 in plus, x3 y3 in minus. Got it? Okay. Now you see what come x1 y2. I wrote x1 y2. What it is there? I wrote it x1 y2, and I should write this one. But I wrote x1 by 3 minus x1 by 3. See, minus x1 by 3. Why I wrote here? I will say x1 by, so that means 12. 12 is brought near to 13. 12 is brought a 1 to x1 by 2. That means 12. 12 is brought near to 13. Okay. These two you have to write side by side. Then see what is happening. That is 21. So 21 is there. Another one is 23. So 23 is brought near to 21. You understood? 2, 3. x2, y3. See, x2, y3. x2, y3. This one is brought near to 21. That means x2, y1. 23 brought near to 21. 12 brought near to 13. With sign, huh? 23 brought near to 21. And 31 brought near to 32. 31 brought near to 32. That one you have to remember. 12 brought to 13. 12 and 13 side by side. 23 and 21 side by side. 31 and 32 side by side. Why I will tell you now. Now what is there? Why you brought near to each other? Because you have to make the x1 here common. You have to make the x1. Otherwise you can think like that also. x1 by 2. Here x1 is there. Where is another x1? x1 is here also. So these two can be written near by near. Side by side. So x1 is here, x1 is here. They are right. You can write them side by side. Then here see x2 is there. But minus should not be written first, plus will be written first. Where is another x2? See now x2. So x2 plus x2 you write first, then minus x2. y1. Then x3 plus, x3 minus. First you write the plus. Here is plus x1 y2 minus x1 y3. Here plus x2 minus x2. Plus x3 minus x3. Like that you can arrange also. Okay, by which we can take common from them. Look, from these two, what is common? x1 is common. Taken out, it is remaining y2 minus y3. Next, x2 is common, taken out, and it is y3 minus y1. Clear? Now x3 is common, then what is remaining? y1 minus y2. Clear? So this is the area of the triangle. That is, I wrote it here, area of the triangle equal to half into x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. I already did a skeletal figure for you for this representation. I did it, and also I wrote the notice board here that this is very, very important. Please try to remember. You will think that, sir, this is a very difficult formula to remember. It is too big. Don't say like that. Please say how can you write it very easily. I am writing it easy in a easy method. See, that is equal to half into, I am writing, see, x into y minus y. You write this term, x into y minus y 3 times, plus x into y minus y, plus x into y minus y. You like that you write 3 times. Clear? What I wrote? X into y minus y plus x into y minus y. Same term you write 3 times. Clear? Then what is your number? 123. See, 1, 2, 3. This number you have to remember. 1, 2, 3, 123. Then it is 231. 123, 231, and this is 312. So 3 numbers you have to put. That is 123, 231, and 312. Put it. 123. Now I am writing 123 and 231 and 312. If you will write like this also, your formula will be it will be easy for you to remember. So what I did half into x into y minus y, x into y minus y to be written to another 2 times. This one to be written another 2 times. Then you have to put the numbers. What is the number I said you? 123, 231 and 312. 312. Here it is written that 123, 231 and 312. This is called as the area of the triangle. The derivation of the area of the triangle in coordinate geometry. So it is a lot of difference you can observe from the area of the triangle by coordinate geometry. That is not half into base into height. That is coming a big formula. It is coming x into y minus y plus x into y minus y plus x into y minus y. 1, 2, 3, 123, 231, 231 and 312. So 123, 231 and 312. I put lighting x into y minus y 2 times and put these numbers. You can easily get the formula of the triangle. So I hope you understood this part. The sums related to the area of the triangle, I will do it next. So next I am going to explain you about the collinearity. What is that? About the collinearity. Now come to the next part. The next part is also very important. Many questions will come from this collinearity. What is that called as? Collinearity. Collinearity, they will ask 2 marks or sometimes also 1 mark, half mark questions are also available from this heading. That is called collinearity. Let's discuss about it, collinearity. Then what is collinearity? Look, I am taking some points here, A point, B point and C point, and I wrote here collinear points. And I took some points here A, B, C, and which is a little bit here and there, and I wrote here non-collinear points. So what is the difference between a collinear point and a non-collinear point? Right now we are going to discuss about it. See now, when I am saying about the point A, B, C, they are in a same straight line. They are in a same straight line. For that reason, these 3 points are called as collinear points. Then what is the definition of a collinear point? The points which are on the same straight line, that is called as the collinear point. That means collinear points, if you will join, you are going to get a straight line only. Okay, now here this straight line, we can say a straight line is the set of a lot of collinear points. A straight line is the set of lot of points and which is giving you a straight line. So these all points are called as collinear points. I hope you understood it. Now you see, your points are not right now in order. One point is here, see that A point I put, A point is here. So now you can able to understand nicely. See what I did. See now 3 points I took, same 3 points A, B, C. I took it here and there. So they are not in a same straight line. Then when you will join, definitely these non-collinear points are going to give you a shape. What is this? Right now let's join it. Then after that we will look what type of shapes it is giving to you. So now you see I am joining these points. See now what I got? I got a shape of a triangle. So triangle needs 3 non-collinear points. Triangle needs 3 non-collinear points. So definitely 4 non-collinear points are also I took to get a square. So this is the definition of non-collinear points. Non-collinear points are never giving you straight line. So the points which are not in straight line, the points which are not in a straight line and which is giving you some geometrical shapes, those points are called as the non-collinear points. So there is a condition. What is that? See now, condition for non-collinearity. That means 3 points will come in a same straight line. These 3 points will come in a same straight line. What is the condition for it? The condition related to the area of the triangle in coordinate geometry. In coordinate geometry, you are saying the condition for collinearity is related to the area of a triangle. What is that? Area of a triangle. So what is the area of a triangle? The area of the triangle, the condition is the area of the triangle must be equal to 0. VBI, very important. Try to understand it nicely. The area of the triangle, when it will be equal to 0, then the 3 points A, B, C can be called as the non-collinear points. Understood now? So area of the triangle is 0. So right now they are the collinear points. When the area of the triangle will be equal to 0, then this ABC will give you collinear points. That means they are in collinearity. They are collinear points. So ABC will come in a same straight line when the area of the triangle will be equal to 0. If the area of the triangle is not equal to 0, then definitely there is a shape of the what? Shape of a triangle. So definitely these 3 points are non-collinear. So when the area of the triangle is equal to 0, these points are called as collinear points, and that is the condition for collinearity. Understood now what is collinearity? If you are saying collinearity in coordinate geometry, then the area of the triangle will be equal to 0. What is the area of the triangle? Half into, I said you, x into y minus y plus x into y minus y plus x into y minus y. Again put the numbers 1, 2, 3, 2, 3, 1, 3, 1, 2, and write it. That area must be equal to 0. If x1, y1, x2, y2 and x3, y3 will be given to you, you have to put your values and you see whether it is coming 0 or not. If it is coming 0, then definitely ABC are collinear points. That is called as the condition for collinearity. I hope you understood it. Now come to the next part. The next part of coordinate geometry is area of a triangle by Heron's formula. Now we just before we calculate the area of the triangle by using coordinate formula method. Now you are going to calculate the area of a triangle by Heron's formula. Heron's, he is a mathematician who derived a formula for the triangle, especially for scalene triangle. Now I am going to explain you what is that Heron's formula in triangle. Look at it. When Heron's formula we are applying, definitely the triangle will be a scalene triangle. Scalene triangles are the triangle where no sides are equal to each other. So here it is, look, 3 cm, 4 cm and 5 cm. And for your kind information, angle A, the angle A opposite side, look at this. This is ABC triangle. A angle opposite side is called as small a. This is called as small a. I took it as 5 cm. That means BC is 5 cm. BC is the small a. Now see, B angle opposite is called as small b. Small b. That is, I took it at 4 cm. That is AC. That is 4 cm. Now C angle opposite I took small c. That is, let it be 3 cm. AB. So A angle opposite is small a. B angle opposite is small b. And C angle opposite is small c. That is the symbol for the sides. A, B, C. Okay, I hope you understood. And it is a scalene triangle, especially. Why? Because the sides are not equal to each other. So in this case, what we will do? See now, first of all, you go for the perimeter. Perimeter. What is the perimeter? Perimeter is called as the sum of the 3 sides. So sum of the 3 sides means A side, A plus B plus C. A plus B plus C. Small a represents BC, small b represents AC, and small c represents AB. So you add these 3. Then I am saying you half perimeter. This is giving you perimeter. Then what should be the half of perimeter? Half of perimeter means this by 2. A plus B plus C by 2 is called as your half perimeter. Our area will be on this basis, half perimeter. See now, half perimeter can be written as S. I put a symbol for this, that is S. Half perimeter equal to, let it be S. Then area of the triangle is, direct formula you apply, that is, according to Heron's, the formula is S into S minus A into S minus B into S minus C square root. Square units, because it is area, so it will come under square units. But the formula is S into S minus A into S minus B into S minus C square root. Okay, so S is half perimeter. Perimeter you take, then divide it by 2, S will come. Then ABC, A I side you small a, angle A opposite side, that means BC. B is angle B opposite side, that means AC. And C is your angle C opposite side, that is your AB. You put it there and get your area of the triangle by Heron's formula. But this is the formal. This is formal. This is not in your Cartesian plane. But when this triangle is belonging to the Cartesian plane in coordinate geometry, look at it how I am doing. I shifted this triangle to here C. Now what happened? You have to take a two axis for it. One is x-axis, y-axis, and you take a triangle in your quadrant. Then you put the name ABC and get the coordinates of AB x1, y1, B is x2, y2, and C is x3, y3. Now for this x1, y1, I took some coordinates by which I can able to explain you how the area will be calculated. See now, x1 is x1, y1, that is 1, 1, x2, y2, that is 1, 4, and x3, y3, I took 5, 1. Okay, now we don't know this side. This A we don't know. So we have to calculate what is the BC. What is the BC? We have to calculate. How will you calculate BC? The BC calculations will be by distance formula. Will be by distance formula. B to C is the distance. So you have to calculate BC by distance formula. Similarly, AC by distance formula, because you know the coordinates C, 1, 4, 5, 1. So you can easily calculate the BC measurement by putting distance formula, and AB also by putting distance formula. See now how I am doing the sum and completing the area by Heron's formula. See now, what is your A point? A is 1, 1, that is x1, y1. B is 1, 4, that is x2, y2. C is 5, 1, that is x3, y3. Then what I calculate? AB. A to B distance I am calculating. That means, what is the distance formula? X2, what is the distance formula? X2 minus x1 whole square plus y2 minus y1 whole square root. That is the distance formula. Here it is put. See, x2 minus x1, that means 1 minus 1. 1 minus 1 whole square plus y2 minus y1, that means 4 minus 1 whole square. Now 1 minus 1 is 0, so no need to square. Then 4 minus 1 is 3 square, 9. 0 plus 9, 9. 9 square root, 3. So we got our AB side as 3 units. AB side is 3 units. AB side means the small c. AB side means the small c. C angle opposite. That means AB. Small c we got 3 units. Now similarly, what will be your BC? Take B to C. Then this is x3 minus x2 whole square. That means 5 minus 1 whole square. 5 minus 1 whole square. AC. You are taking AC. AC. So it is 5 minus 1 whole square plus 1 minus 1 whole square. 1. Here it is 1 AC, 1 minus 1 whole square. So it is 1 minus 1 whole square. It is 1 minus 1 whole square. So now it is 0. Look at it. 5 minus 1 whole square. It is 4. 4 square, 16. Okay. Now plus 1 minus 1, 0. 0 square, it is 0. So no need to write. So square root of 16 is, square root of 16 it is giving you what? It is giving you 4. That is equal to 4. 4 units. Clear? Now you see what is your BC can? B to C. It is coming here 4 units. Please write here 4 units. 4 units. Clear? Now come to the what? AC. Sorry, AC. I right now took AC. AC is 4 units. Came. It is 4 units. Now took BC. What is your BC? BC. That is 5 minus 1 whole square plus 1 minus 4. 1 minus 4 whole square. That is equal to 25 square root. That is equal to 5 units. 5 units. Understood? BC. AC came 4. AC came 4. So AC is AC. A to C is coming 4. So B angle opposite, that is small b, is 4 units. 4 units. So now BC came 25 square root, that is 5 units. B to C, that means A. Small a is coming 5 units. It is coming 5 units. Now what will be your half perimeter? A plus B plus C. 5 plus 4 plus 3. 5 plus 4 plus 3 by 2. Half perimeter by 2. 5 plus 4, 9 plus 3, 12 by 2, 6. Next, for the area of the triangle. What is the formula? S into S minus A into S minus B into S minus C. Very easy. So now S is 6. 6 into 6 minus A is 5. 6 minus 5. B is 4. 6 minus 4. C is 3. 6 minus 3. Now it is 1, 2, 3. 6 into 1 into 2 into 3. 6 1 is 6. 2 is 12. 3 is 36 square root. That is giving you 6 square units. So this is the theory behind the Heron's formula by coordinate method. Sometimes what will happen, these measurements will be given directly, but in when he is acting in coordinate geometry, definitely he will give you the coordinates. You have to find out the measurement by putting distance formula. That is most important. Distance from this one you have to do. Then you will go to the half perimeter. Then you will calculate the area. That means this type of questions may come in 4 marks also. So be careful for your sign conventions, signs, positive and negative. Sometimes the coordinates will be negative also. So be careful for when you are calculating the distance and when you are calculating the square roots also. Okay. So now go to the next part. Now come to the concluding part of this coordinate geometry. The concluding part of the coordinate geometry is the slope of a line joining 2 points. That means the line is there which is joining 2 points. What is the slope? Slope means the angle created with x-axis. The angle created with the x-axis. What is this line creating angle with the x-axis? So this is the thing we are going to discuss it now today. So first of all, you have to know what is a line. A straight line. A straight line is always a set of points, and also straight line can be represented by y equal to mx plus c. Y is equal to mx plus c. The formula for a straight line, y is equal to mx plus c. Okay, try to understand that. Next, I wrote it here. See, I took a quadrant now. In a quadrant, my 2 points are there. Line joining 2 points. So my 2 points are A and B now. A coordinate is x1, y1 and B coordinate is x2, y2 now. Let the name of the line is L, and the line is creating with x-axis. Let the angle, that is the angle is equal to theta, and passing through the origin. So now you see in x coordinate, let it be x1, y1. So what is in x-axis? What is the measurements? So if I am putting here, it is 0. So now what is Z? O to D. O to D is x1 and O to E is x2. So this is x2. So what is this much? This much is called as x2 minus x1. From here I drop one perpendicular to the x-axis, that is AD, and from B I drop a perpendicular, that is called BE. And I joined a parallel line, that is AS, which is parallel to DE. AS parallel to DE. Clear? In Y abbreviation, in Y coordinate, look from here to here, from here to here, it is y2, and from here to here it is y1. So what is this small distance? This small distance is y2 minus y1, y2 minus y1. So all are ready now by measurements. Now what I wrote, you see, there is a relation between the ratio in change in y-axis to x-axis. If the line, see now, the line is changing its positions in x-axis, and also it is changing the positions in y-axis. Look here, when it was here, then now the point is here. So now you see y-axis position is here and x-axis position is here now. The line is changing the position, again it is coming here. See now. So now it is here now. What is the position now? Here. So it is changing the position in relation to the x-axis. X measurement is going to change, means y measurement is going to change also. Clear now? So that is the thing it is written here. Between the ratio of change of y-axis to x-axis. Y-axis to x-axis. That means x coordinates changing, y coordinates are alternatively changing. Clear? So there is a change in y-axis and change in x-axis also. On line has relation with the angle made by it with x-axis. What is the angle made by it with x-axis? Let the theta. When theta is gradually changing, definitely there is a change between the what? Between the coordinate of the points or the points. The coordinate of the points in y-axis to x-axis, there will be a change. So change in y, change in x will be observed also. So I hope now you understood this up to this much. Now you see what I take. I took a coordinate at x1, y1 and b coordinate as x2, y2. Be 2 points on the line L. What is the line? That line is called L. That is a straight line. Then what is the slope of a line? We are going to find out the slope. Slope of a line. So what is the slope of a line? I said you, according to an angle it is changing. Change in y-axis to change in x-axis. So let the slope be AB. And the slope denoted by small m, don't write big M, small m. Small m equal to change in y means First it was in y2, then came to y1. y1 to y2 helping. It is going to y1 to y2. So right, definitely it is y2 minus y1. When change in x-axis means this is x1, this is x2. So x2 minus x1 is the change. y2 minus y1 is the change in y-axis. This is the change. y2 minus y1, and this is the change in x-axis. That is x2 minus x1. So first y by x, then y2 minus y1 by y2 minus x2 minus x1 is the formula for the slope of a line. So now slope of a line denoted by small m, and the line L makes an angle theta with the x-axis. Now it is making angle theta with x-axis, and the slope m is equal to, in trigonometry version we can say that is tan theta. Again say me with me, because it may be a new for you. So tan theta. What is tan? Tan means tangent. Tan theta is equal to, the slope can be called as tan theta also. So tan theta equal to change in y by change in x. Change in y means y2 minus y1, change in x means x2 minus x1. So tan theta equal to y2 minus y1 by x2 minus x1. This is the formula for the slope. You should remember it. Okay. So I wrote it here. What is tan theta? Tan theta, it is in a right angle triangle. Tan theta is perpendicular by base. In trigonometry it is used. Right now it is a right angle triangle. So perpendicular by base. Perpendicular means y2 minus y1. Base means x2 minus x1. So this is the concluding part of the coordinate geometry, that is called slope of a line joining two points. I hope you understood this coordinate geometry chapter nicely. Go through the videos very carefully and seriously. Listen the video very seriously and also try to make your running notes, your important notes in it, and try to do the sums according to the heading. Suppose you are doing right now the video is slope on the line joining two points, then try to do the sums of this concerned topic, and after that it will be easy for you to go through the textbook nicely. I hope you all understood this coordinate geometry nicely. It is a very important chapter. Take care of it. Stay home, stay safe. Thank you very much.